Okay, so I wanted to do a programming problem from the book. So I'm going to do 5.7, which is a rock, paper, scissors game. You could read the description here, but it basically just says to emulate the rock, paper, scissors game that you play on your hands and keep track of the wins and the losses. So we're going to have to randomly generate a choice for the computer. So the best way to do this is use a 0 for rock, a 1 for paper, and a 2 for scissors. Then we can map that to be a rock, paper, scissors. So here's my program so far. I import the scanner class because I'm going to prompt the user for data. Then I created some class constants. So these are static and they're outside of the main method. So I created constants for rock, for paper, and for scissors. So I basically gave them values of 0, 1, and 2. And then inside my main method, I instantiate a scanner object. And then I have 3 variables. These variables are going to keep track of the wins, the losses, and the ties. And then I have 2 variables. So these variables are going to be for the user and for the computer. So I'm going to prompt the user to enter in a 0, a 1, or a 2 to indicate his choice for rock, paper, scissors. And I'm going to store that data into user. And then for the computer, I'm going to randomly generate a 0, 1, or 2. And that's going to be his choice for rock, paper, scissors. I created this additional static method. So what this method is going to do, it's going to take in a value. And if the value is 0, it's going to say that it's a rock. If it's a 1, it's going to say it's a paper. And anything else, it's going to say it's scissors. So I'm basically going to use this to get the string out of this number. So whenever we get a number from the user or generate a number from the computer, we can get the string for that number that they chose. So if they chose a 0, we're going to give the string rock. So if you pass in a 1, we're going to pass out paper. And anything else, we're going to say is scissors. So now what I'm going to do is I'm going to work on my game logic. I did create a Boolean variable. This Boolean variable is going to control my loop. So the first thing I want to do is prompt the user for data. So here's my game logic so far. So the first thing I do is I just tell the user, let's play rock, paper, scissors. Then I give them a menu and then I ask them for their choice. They're going to get their choice right here. I'm going to enter into a while loop. So I'm going to prompt them until they give me some correct data. So the user has to enter in a -1, a 0, 1, or 2. A -1 to quit, a 0 for rock, a 1 for paper, and a 2 for scissors. Anything outside of that range, I'm going to tell them it's an invalid choice and prompt them until they give me something valid. Then I'm going to set my done variable, and my done variable is controlling my loop. So if the user entered a -1, then done is going to be true. But if we're not done, then we're going to continue on with the game. So if we're not done, we're going to continue with our logic, but all I'm going to do is just print out what the user entered. And then I added this line just to create some space. So let's go ahead and compile and run this program and see what it looks like. So here's my menu. The first thing I want to do is test -1. So if I enter a -1, the program does finish. Now I'm going to enter in a 0. It tells me that I chose a rock. I'm going to enter a 1. It tells me that I chose paper. I'm going to enter in 2. It tells me that I chose scissors. And then I'm going to choose something outside of the range, like a -9, invalid choice, +9, invalid choice. Okay, so this looks like it's working. So I'm going to continue on with my game logic. So the next thing I want to do is I want to generate the computer's choice and print out what the computer chose. So here's what I'm doing for the computer choice. I'm basically randomly selecting 0, 1, or 2, and then I'm printing out this choice. So now what I want to do is I want to do my comparisons. The easiest one to do is check for a tie. So here's my check for a tie. Now both of these are integers, so if they're equal to each other, that means they chose the same thing. So then I print out it's a tie, and I increment ties. Now the next check I want to do, I want to see if the user won. So here's my logic. Now this is a little more complicated. So what I'm doing is I'm checking each case. So if the user selects rock and the computer selects scissors, then the user won. If the user selects paper and the computer selects rock, then the user won. If the user selects scissors and the computer selects paper, then the user won. So these are the statements I output when the user wins. I basically just print out what beats what, and I say you win, and I increment wins. Then all other cases, the user loses. So I print out what beats what, then I print out you lose, and then I increment the losses. Now there is an easier way to do this logic here, but I'll talk about this later. So the next thing I want to do is just output the totals outside of this loop. So when the user ends the game, he can see his wins, his losses, and his ties. And here's what I'm printing out once I leave the loop. I'm just saying game over. I'm printing out the wins, I'm printing out the losses, and I'm printing out the ties. So that's pretty much it. I think I covered all the bases, but let's go ahead and compile and run this program and verify that it works correctly. So I'm going to choose rock. Computer chooses rock, it's a tie. I'm going to choose rock again. Computer chooses rock again, it's a tie. I chose rock, computer chooses paper, I lost. I chose rock, computer chooses scissors, I won. So I'm going to choose paper. Computer chose scissors, I lost. I chose paper again, computer chose paper, it's a tie. I chose paper, computer chooses scissors, I lost. I chose paper, computer chose paper, it's a tie again. Finally, I win when choosing paper. So when I chose paper, computer chose rock, so I won. Now I'm going to move on to choosing scissors. Computer chose scissors, we have a tie. I chose scissors, computer chose paper, I won. So this time I chose scissors, computer chose rock, and I lost. So it looks like this game is working correctly. So now what I'm going to do is press -1 to quit. And here are my totals. So I had 6 wins, 4 losses, and 10 ties. Now the last thing I want to talk about is the logic that's right here. Now there is actually a pattern to this. So if I have rock, paper, scissors, and I give rock the value of 0, paper the value of 1, and scissors the value of 2, now whenever I compare an item to the thing greater than it, then it's a loss. So a rock loses to paper, paper loses to scissors, and scissors loses to a rock. Now I know we go from 2 to 0 here, but if we flipped on our highest value, meaning once we got to our highest value, we reset back to 0, the next thing in line, which is the rock, would have beaten the thing previously. And with the same pattern, if I go backwards, then I have a win. So rock beats scissors, scissors beats paper, paper beats rock. So when you look at this, there's actually a pattern. So when we compare what the user chooses to what the computer chooses, if we take what the computer chooses plus 1, and we compare these two, like if we're checking for equality here, let's just say the user chose paper and the computer chose rock. Since rock plus 1 is equal to paper, then we know this is a win for the user. However, if the user were to choose a rock and the computer were to choose scissors, but 2 plus 1 is really 3. So really what we got to do here is just take what we have here and then find out what the remainder is when we divide it by 3. So if we take 2 for scissors and we add 1 to it, that's going to give us 3. Then we find out what the remainder is when we divide it by 3, that's going to give us 0. So this math will check out. If we go back to the previous example, the computer chose rock, which is 0. We're going to add 1 to that, and then we're going to try to divide that by 3 and get the remainder. The remainder of that is still going to be 1. So this math also checks out. So we could simplify our logic where we're checking for a win to use this expression. So I'm going to go ahead and change this expression. And here's my new expression. So if we add 1 to whatever the computer chose, we divided it by 3 and got the remainder. If that number is equal to whatever the user chose, then we know the user won. So for instance, if the user chose rock and the computer chose scissors, then the scissors, which is 2 plus 1 will give us 3. Then we divide by 3, the remainder of that would be 0. So we have a 0 is equal to 0. If this is true, then we know that the user won. Now I know this might be a little complicated to understand because it's a little math intensive, but if you prefer to have it the other way, you can keep it the other way. But I just wanted to show you there's another option we can use to make our expression smaller. So I'm going to go ahead and save this and compile and run it and verify that we're still getting the same results. So I'm going to choose rock until I win, lose, and tie. So I lost to paper, I won to scissors, and I tied with rock. Now I'm going to choose paper until I win, lose, and tie. So I lost to scissors, I tied with paper, and I beat rock. Now I'm going to choose scissors until I win, lose, and tie. So I tied with scissors, I won against paper, and I lost to rock. So that's it. That's the rock, paper, scissors game. I feel like it's not too difficult. I mean, I know there's a lot of programming statements in here, but you should just take it step by step. Really, the logic is just based on things we already know. You know, if you choose a rock, then you're going to lose to paper. If you choose scissors, then you're going to lose to a rock, and so on. So we just put all that logic in here, and then I had these variables to increment so I can count my ties, wins, and losses. But I had this inner loop when I was doing the check to make sure that we had a valid input. And then when I leave the loop, I just output the totals for the wins, losses, and ties. So I did create this method because I felt that it was easier to determine what we chose, rock, paper, scissors, based off our number. So all we do is just pass in our value and then we get back a string.